This event is part of a series where college deans share with the Northeastern University community the resilience, innovation, and strength learned throughout the pandemic at their colleges. We are honored to have Dean Gregory Abowd's enthusiasm for this event. Dean Gregory Abowd is a world-renowned scientist known for his work in human-computer interaction and ubiquitous computing. He joined Northeastern University in March 2021 after 26 years at Georgia Tech, where he was a Regents Professor and held the J.Z. Liang Chair in the School of Interactive Computing. A highly respected computer scientist, Gregory empowers students, alumni, faculty, and staff to push beyond traditional engineering disciplinary boundaries for the ingenuity needed to make technology advances more self-sustaining. He believes that different perspectives are needed to solve real-world global challenges and promotes an interdisciplinary approach to engineering education. Without further ado, we welcome Dean Gregory Abowd.
Thank you very much, Diana. And welcome everyone, and thank you for joining us for this interesting and I hope thought-provoking panel. It's called, Beyond the Pandemic, a conversation with Dean Gregory Abowd, but fortunately for you, we have the chairs from the various departments of the College of Engineering are going to be providing their disciplinary and broader perspective on a number of topics that I think are relevant here. We all know that things have changed over the last 2 years. They were forced into a particular change, and we're never sure exactly when we're going to get back to any sense of normalcy. This has caused a concern for individuals, stress for individuals, but also it's provided us the opportunity to change and reflect on the way we did things in the past and what might be a different way to view engineering challenges and education going forward. And I'm inviting my colleagues here to comment on a number of those topics. As Diana mentioned, we have a chat available for the participants, and we welcome you to put any questions you have in there. And I and others will try to weave those into the discussion. What I'd like to do is introduce to you our moderator for today, one of our alums. I'm very pleased to introduce to you Ahmed Zamli, an industrial engineering alum from the class of 2014. Ahmed is an entrepreneur, and he founded Untitled, which is a vertical indoor sustainable farm bringing fresh and healthy greens to consumers and businesses. Ahmed is a very proud Northeastern alum, being a member of the Young Alumni Advisory Board and a young global leader for the university. So I'm going to now pass the baton on to Ahmed, and he will facilitate and moderate this conversation. Thank you.
Thank you so much, Dean. It's a pleasure to be here, and it's a pleasure to moderate this really, really interesting conversation. The pandemic really did affect a lot of us in a variety of ways, but I think it's very exciting times to see what comes out of it. It's a huge shift in the way we do things in business and education. And I'd love to introduce our amazing panelists today, starting with Professor Hajar, who's the chair of Civil and Environmental Engineering, Professor Makowski, who's the chair of Bioengineering, Professor Minus, the chair of Mechanical Industrial Engineering, my alma mater, Professor Tadigadapa, the chair of Electrical and Computer Engineering, and Professor Willits, the chairperson of Chemical Engineering. I'd love to dive right into the questions that we have to get the conversation going a little bit, and start with the first one, that we've all felt the fallout of this pandemic. It's really touched us in a variety of ways, our businesses and our lives, and it's changed the way that we've done things. And I'd love to get your opinion on how you're considering to change the curriculum for ways that engineers of the future would be able to design contingencies to deal with disruptions that we've dealt with during this pandemic, like the supply chain issues and whatnot, and how you're going to plan the curriculum going forward for engineers of the future. Professor Willits, would you like to chime in on this?
Sure. I think that, we've seen a lot of differences in how we educate and really things that maybe weren't the norm have had to become the norm because of what was pandemic, like flipped classrooms and really engaging students on project-based learning, because we can't always be there as faculty. But I think that then the idea of in designing for the future, to some extent, the pandemic has showed us that we don't know what's going to happen, right? We are perpetually unprepared for the next thing to come to us. So as engineers, we have to embrace that. And we have to really think about, well, how do we slow down that change? How can we better predict those changes? How can we really think about what are the supply chain potential issues and address those before they happen? I think that in chemical engineering, that they had to be, the reason why we didn't have a vaccine, an mRNA vaccine, is because we can't deliver it. Well, we can deliver it now because there is money put behind it. Engineers figured out how to do it and we could do it, right? So now it's a matter of what's the next thing? How do we deliver those things that we previously thought were just not really feasible? And so I think that leaving open that imagination, really getting students all on board with the impossible being possible, and thinking about what are these future issues that maybe we don't exactly know now. I tell students all the time, we are not training you to do a job that you'll get today. We're training you for a job that you don't even know exists yet, because it doesn't, right? There's so many changes that have happened even in 5 years that the students have to be flexible in how they deliver and what they deliver. So I think that that's really become key components of what we do, and integrating that with this global issues, inclusive issues, like how do we deal with societal upheaval? All of those things come back into how do we train our engineers? And I think that those are all really important.
Very interesting that the comment you made about training the engineers to have a job that doesn't exist, that's resonates very close to home, because the job I'm doing today didn't exist while I was in college. And it's kind of a new and evolving field. Professor Makowski, I'd love to.
Sorry, I think I may have just, can you hear me? Okay, good. All right, so the pandemic for bioengineering was really almost felt like a bit of a whiplash, and I think Dean Abowd said it right. There was huge stress on a lot of our faculty and students, and at the same time in bioengineering, huge energizing, because there were so many opportunities that became clear, and that's both in terms as well as the new foci for research. I mean, what we learned March of 2020, we learned in a few days we did deliver our educational content remotely when we had to, and for the most part that worked. I mean, there were a couple of bumps in the road, and over a period of literally a few days we made it work. And then over the period of the next 6 months, we figured out how to work in a hybrid mode, how to interact with students who couldn't get to the US because of visa issues, about how to deal with the changing climate of public health. And we found out that we became really good at a very flexible approach to the delivery of education. And what that has done is gives us huge opportunities in the future to deliver content in different ways. Some of our young faculty who had young children who day to day didn't know what their childcare situation was going to be, turned out to be just extraordinary in the way they were creative, in the way they delivered their courses. I mean, we had a bunch of young parents who were being given just great feedback from their students about the way they were working with the students to cope with the stresses the students were under, the stresses the faculty were under, and yet the energizing feeling that bioengineering was beginning to make an impact on the entire world. And I think that that brought out a lot of really a lot of energy in lots of ways. I would say that, you know, a half dozen of our faculty changed at least a portion of their research effort to start directly addressing some of the problems that were brought up by the pandemic. We developed a 4-credit course that we delivered on engineering against COVID-19, about how engineering was actually directly working towards engineering. And I think that that's the sort of thing that we're going to spend more time thinking about in the future, because public health, in a very real way, is in many ways engineering. And if you think about little things that people never, you know, at least, you know, didn't pay that much attention to before, I think we're going to pay more attention to it in the future. I think, for instance, design of ventilation systems in buildings. I mean, Professor Hajar is going to tell us, well, we always worried about that, but we may be paying a little more attention to filtration and to circulation in the future, and how to minimize impact on public health when we see a tick up in respiratory issues. I think that vigilance is something that is probably going to be more and more engineered into our public systems. You know, nowadays you can go to the newspaper and read about what's the count on COVID-19 DNA in the Boston water supply. 2 years ago, how many people knew that such a thing could exist? And now you can just go and check it out all the time and predict what the public health situation in the city is going to be in a week. I think we're going to see a lot more of that. There's a lot more opportunities that are like that are going to impact all of engineering, in particular bioengineering. I think another thing that came out in the pandemic, which made a lot of us think, was that for all of the huge amount of data that was being collected, some of the projections were really not all that great. And I think part of it was that we were learning that the data, a huge amount of data, doesn't mean the data is of high quality. And I think a lot of the data was low quality only because it was being collected in entirely different ways in entirely different places. And, you know, for all of our efforts in big data and artificial intelligence and machine learning, there's still a long way to go in order to try and understand how better to cope with data of variable and sometimes hard to assess quality. And I think we're going to see a lot of that. I think part of the issues may also have been modeling of human behavior. You know, how many people still wear masks without going over the nose? I mean, you know, there's some variables that we still haven't figured out how to deal with. I think what the pandemic has done in the field of bioengineering is it's thrown up a huge number of challenges. And there's a lot of students out there that are really excited about the challenges. And you know, I think our curriculum is in a pretty good place to help them give some of the tools to go move forward on those challenges. So it was a terrifying and difficult time, but also for many of our students and faculty, a really energizing time, a time to really spark creativity and innovation. So it's hard to know how to think about that. A lot of people had a very hard time. A lot of people, you know, found it very energizing.
It is a really interesting time to see how research is going to evolve with what we've learned over the past couple of years going through this. I mean, the last time globally we've gone through this at such a large scale was over 100 years ago. And I think now we're in a technologically much more advanced stage, understanding a lot of things in a different light with more resources. So I'd love to dig into how research is going to be focused from all of your disciplines. What new topics of research are you going to be exploring, and how is the style of research going to change after what you've learned over time? Anyone can chime in here. Professor Willits, I know you're itching to answer this question, but if anyone wants to chime in, more than welcome.
Yeah, I think I briefly mentioned it, and I think Lee pointed out really some of the key elements of how research is changing. And a lot of us pivoted in all towards COVID, but in a various different ways, right? I think that, how a chemical engineer would do it is different than how a BioE might do it, and different how a civil engineer might do it. So I think that all of those things in pivoting, flexibility and agility on our end for research has been really key. But I think also then some of what happened and how it happened really highlights some of the issues that we have in research in general, and topics became really much more topical. For example, how do we study differences in processing and developing vaccines, and how does the immune system work? Can we look at those different elements from an engineering perspective and really drive them forward? But I think advanced manufacturing is another really key thing, because between automation, data, all of these things really come together really nice in advanced manufacturing. And I think that, MIE has been driving that for a while, and really I think the highlight, and it's really become highlighted over what's been going on in the pandemic.
Ahmed, I just wanted to address a question I think I just saw in the chat about how did it impact research, and the short answer is we really took a hit. In March of 2020, all of the research labs shut down, and we went through a safety review about how are we going to be able to bring our laboratories back up in a way that's going to be safe in a pandemic. I mean, a lot of lab work. It's here, do this, and hands-on, literally hands-on, in order to train a student how to do a particular technique in a laboratory. And so we had to rethink a lot of that. All of our labs in summer of 2020 were reopened through huge effort on the part of our safety coordinators. And they were reopened with enforced social distancing. Enforced social distancing, well, I'll tell you, it's hard to show someone how to work a confocal microscope at 6 feet distance if you really want to. And yet we figured out a way. Most of our faculty took a hit and lost 2 or 3, in some cases much more, months worth of effort. But what we did was we came up with just basically we raised the bar in terms of maintaining safety in the laboratories. All of the safety procedures were reinstated and reinvestigated in terms of how do we do this without infecting one another. And it worked out really well. The number of lab personnel to lab personnel infections, well, I'm not aware of any. And people were very careful. And of course, the testing, which was originally twice a week and became once a week, we basically were able to identify anybody who was infectious very, very quickly. I would think now our labs are pretty much back to where they were, probably a little bit less densely packed than they were pre-pandemic. But in some cases, that's just a matter of we figured out ways to reschedule people's work.
Professor Tadigadapa.
Yeah. So I give you an electrical engineering perspective, a little bit different from the ones that we have heard, which we prepared for this in some ways without knowing about it, in the sense that the computing era and the communications era was already there. I mean, it was catalyzed one way or the other by research that was already in place. And what we did as the pandemic hit, and it's a huge thing that we don't think about it, of course, including the mRNA vaccine, actually, a lot of that is already in place. What we were able to do was pivot instantly because all that technology base existed. So while we were not thinking about a pandemic or something like that, unexpected situation, somehow we had the technology base that allowed us to very quickly pivot towards addressing the challenges. Moving forward, if I think about where will we go, so I will say from an electrical and computer engineering standpoint, computing, communication, a third one for me would be cognition. Really where we are moving towards from that standpoint is what I will call an awareness engineering, if you wish to. Whether it's augmented reality, when you look at all the kind of things that are happening now, that's where we are heading. What does this do? This does give us the possibility in future for maybe vicariously experiencing things. Maybe that's not the right way of putting things, but that gives us opportunities that I I can't imagine, that we are able to use in situations I can't predict. So from that point of view, if you think about it, the research that I think at least ECE and some of the disciplines I'm sure we are heading towards is very much in this direction of augmented reality awareness of a situation where we are not present. Actually, we feel it in every which way. And that's quite an incredible target. And that's, I think it's happening as we speak even. And that's where I think future research is also focused on.
Yeah, I think that's very interesting. And what we're doing right now, this didn't really exist at such a large scale a few years ago. And now it's like, tomorrow's Monday and I have a bunch of virtual meetings. Professor Minus.
Yeah, thank you. I just wanted to give the mechanical and industrial engineering perspective, and I know you're an IE alumni, so it's good to see you here. But mechanical and industrial, I think manufacturing obviously is at the center of those two disciplines. And so this was a big area for us. In addition to things that pivot off of that, like supply chains, like logistics, like resilience, like human-centered activities and human-machine interfaces. So all of these things became majorly hot topics, obviously, with the pandemic. And the only thing I'll comment on is, because you can go on and on about different areas of research, but how we went about research really changed because the world needed to adapt very quickly. And so, in academia, we can do our research in our labs. People in industry are doing research in their corporations. We needed to start to communicate more. And so I had a lot of faculty that were working directly with the state and local governments. We had people going out to industry reaching out. And so I think it's fundamentally changed how we do research. Our partnerships are changing. The pace at which we're doing research is changing. Research in this bubble of just your lab is no longer ideal because that's not going to allow us to make the changes and adopt technology at the rate that we really need to be prepared in this situation to get out of it, but also in the next time we have a situation like this. And it kind of also goes to a little bit of Jim's question about labs and needing to deal with things remotely. Experimentalists really felt it. I'm an experimentalist. And so getting to my lab, not being able to, really did put a damper in research, but it made us think about how do we do research without a lab? What other things can we do? How can we leverage our collaborations with people who are doing computational work? How could we use that time for have more meaningful discussion with collaborators? So I think people got really creative in that it was an initial shock at the beginning, but then started to really think about how do you use remote work and remote access to our advantage. In terms of teaching, a lot of people have already commented on it, but I just wanted to add, like, we had to also think about students' access to facilities. So if we couldn't have a lab where they could all come to a shared resource, sending things home, sending kits home, making sure that every student had the same access that we take for granted. We take for granted who has a printer, who has a computer in their bedroom, who doesn't, who has Wi-Fi, who has great Wi-Fi or not. So all of these things came into play, and not only our research, because frankly, PhD students were in the same situation. Some couldn't do their research from remote distances. So I think the pandemic really brought out the human side of all the work that we're doing, and we had to really figure out how to work together with one another in a way that I think we hadn't thought about in a while, because we get distracted in our labs. So just wanted to add that little perspective to the conversation.
Yeah, it's very true. We did feel that during 2020, a lot of our work with the company was experimental, and we were operating actually out of the Burlington Northeastern labs. And it was very tough to schedule people coming in and out and interactions. And we had to keep going. We couldn't press pause. We were on a timeline. So it got us creatively thinking in a way that I never thought we would ever do. Dean Abowd, your hand is up.
Yeah, thank you. I also wanted to comment on how the pandemic forced universities to address how they were going to respond to the pandemic itself. And often the way many universities, including Northeastern, responded was by very quickly bringing together the expertise that was distributed across the campus. People who had relevant expertise in epidemiological modeling or in setting up a clinical validation testing to do testing on your own campus. It brought together people, and the lesson from this is more than just about how engineering research happens. It's about how problem-driven research happens in the world. The way you make an impact is you bring a variety of different perspectives together. And it was very refreshing for me to see many universities having people working together who had expertise that was driven by a problem, even though they had never collaborated before, and some wonderful kind of collaborations resulted from that. And I think that's a lesson in how does a university operate to provide a context for those kinds of collaborations to emerge from its expertise to address the wide variety of problems we know about in the world.
I want to go off script a little bit and keep talking about the point that you just brought up about collaboration, because that's very interesting. And I think Northeastern has started to talk about this interdisciplinary education that we're providing the students of tomorrow, and how is, in the engineering world, how is collaboration between different disciplines? You know, for example, me, if I was previously industrial mechanical, collaboration with my counterparts in other disciplines and me learning off of them and them learning off of me, how is that changing in the coming years? How are you encouraging this collaboration, whether in research or in the classroom or on co-op, for example, for students to be multidisciplinary engineers versus very focused engineers like we had in the past? I know this is I jumped with this question, but it popped into my head, and I'm really interested to see what you guys thought.
I would love to respond, but I would like the chairs to get their first chance to talk about this.
I can just say a quick response, just initially as I thought about it. You know, with the department having two majors in it, mechanical and industrial, you know, a lot of the students will, for example, in our capstone, they naturally want to work with one another. And so capstone design, we have a lot of these teams which have both mechanical and industrial engineers on the teams. We've also worked with chemical engineers, civil engineers, electrical engineers. So we have those kinds of opportunities for students. But then you also think about things like minors, tech electives, you know, +1 programs. There's all these opportunities to sort of give the student a way to customize their pathway and to take classes outside of the discipline, but still, you know, at the end of the day, come out with that degree that they really want to have on paper to show and put on their resume. And so we've been thinking a lot about how to combine majors, minors, master's degrees in ways that will allow students to kind of look at things very differently. So for example, I'm an industrial engineer, but I do a sustainability minor, and then I do an energy systems master's degree. So something very different or something new to think about. But that's just like degree wise. We've also been thinking about courses that we can develop, whether we cross list them with other departments or we work with multiple faculty to do that. I don't think we have enough examples of those types of courses, but I think there's a lot of discussion amongst faculty and amongst the chairs even to kind of try to develop these types of opportunities for students where it makes sense and where it leverages their disciplinary fields as opposed to just sort of an extra class. If that makes sense. Yeah,
of course. Professor Makowski.
Yeah, I just wanted to kind of reemphasize with regard to collaborations what Professor Tadigadapa said a minute or two ago, and that is that the technology was really there at the pandemic, but we got really good at it right away. And you know, everybody in bioengineering collaborates with people in one of the local hospitals or one of the medical schools or people in foreign parts. I find myself now, you know, talking to collaborators in California, Australia, all over the world, and in ways that we wouldn't have thought to do 3 or 4 years ago, but now it's commonplace. I mean, the fact is, you know, I work with neuropathologists at Mass General, and it's so much easier that we can just get on Zoom, you know, once every 2 weeks, as opposed to figuring out how to get over there and spend an hour each way or half hour each way. The technology has become so much more established and reliable that collaborations have been, you know, big increase. I think it's really helped.
Professor Hajar.
Yes, I'll add that the way that Northeastern has structured itself over the years is one of the reasons why it was able to address this pandemic so well. And on the topic that you just raised on collaboration, many of our faculty have joint appointments across colleges, so in 2 different colleges. And some of that certainly came into play here as we adapted our research projects to what was going on in the pandemic in our curriculum. And so as examples, civil and environmental engineering has several joint appointments with marine and environmental sciences. And the work that went on in understanding how to detect COVID-19 in wastewater really brought in a lot of expertise from this. And in fact, not only did we have some of the top experts who quickly were able to understand how to make these detections and how to map that onto what was happening in an urban region regarding number of cases and such, but also they worked together to greatly accelerate creating, I think, what will be a whole new field of doing this for a variety of other contaminants, a variety of other human health issues. I think the utilities around the country and perhaps around the world realized amazingly what a valuable asset they have. And we have a faculty search going on right now that's joint with marine and environmental sciences, very likely to bring in an expertise who will have primary work in an area like this. Another place where this maps into the pandemic, for example, is linking transportation engineering and artificial intelligence and computer science, where the faculty are looking at the future of work and the future of how we're living and how this is going to relate to urban planning, urban expansion, and work from home, and how that's going to be changing our transportation patterns. It's going to be changing our real estate patterns.
Professor Tadigadapa, you're unmuted.
Yes.
Would you like to contribute?
Yeah, I think, I mean, my colleagues pretty much summed it up. I mean, in terms of collaborations, I mean, one of the biggest challenges is essentially when you think about this question of interdisciplinary education, clearly we are on one end saying we have a discipline because it's a degree in one of our, majors. And then what is the purpose, right? And a lot of that purpose is to also understand the language, the culture that exists in the other fields, because it's really a very, very big divide sometimes. You don't realize, we think all sciences are the same, all engineering is the same. It is not. In terms of how research is done, how it is referenced, what the language is, the same words between biology and physical engineering are totally different in what they mean. It's an identical word. The word substrate, I'm sure the biologists look at in a very different way than I look at it. And so what happens is there's a huge amount of, gulf between what we are communicating. So I think one of the big challenges, or one of the big goals, I would say, of this type of interdisciplinary education that we really are focused on is really to look at how to bridge that so that we truly have a greater understanding across the board. And I think, I mean, at least a large part of our goals is focused on that, along with, all the challenges that we are trying to address at this time.
Very interesting. I want to keep going with these questions because this one is actually very interesting to me because I'm an industrial engineer and we got significantly affected by some of this stuff. But the pandemic really stress tested a lot of our global and national and regional systems, whether it be supply chain or public health, whatever it may be. And it broke them in a lot of cases, and sometimes pretty disastrous ways that we're still feeling the effects of. How are you working with and teaching the engineers of the future to build more resiliency in our systems? So for example, in supply chain, the gold standard was just in time and almost zero inventory and cash consciousness. And that killed us because we no longer have inventory and a lot of things were stocked out. A lot of people didn't get Christmas presents. How are we going to think about this in the future?
So I could start with this, although I'll hesitate to say that I have all the answers on such a large issue. But we can already see that there are some changes going on. For example, in the construction industry, and I'm sure in other industries, and we'll see how long-term they are. First, we could step back and say that on the topic of resilience, bouncing back quickly after extreme events, there's been work going on for a number of years, and Northeastern's certainly been a leader on these topics, and it cuts across a variety of fields, impact of climate change on coastal regions, resilience against extreme events, earthquakes, hurricanes, tornadoes, blasts, etc. And that kind of work underpins the thinking because it stretches from core engineering design decisions all the way through, for example, to public policy decisions. And so in the construction industry, they're absolutely acutely aware of the supply chain issues and the huge demand that's going on right now. And this is starting to accelerate trends that had already been going on. One example of that would be modular construction, which has been increasing to try to address issues of sustainability, trying to cut down on the amount of energy that we use in construction and use of buildings, cutting down on the amount of waste, cutting down on the amount of pollution, cutting down on the amount of materials. Fabricating structures in a shop or fabricating using something like additive manufacturing can really streamline the way certain aspects of the whole process are done. And I think things like this are accelerating significantly right now. I think also with respect to supply chain, it gets back to my comments on transportation systems. And I think those are going to be continuing to evolve in whole new ways that are very difficult to predict because with the effects of supply chain come different types of pressures that happen on urban regions. They're affecting the real estate markets. They're affecting where businesses move and where businesses choose to locate. And with that can be major population shifts that I think we still haven't fully felt. So civil and environmental engineers considering all of this.
Professor Minus.
Yeah, thanks. I just wanted to say from the point of view of, where you talked about supply chains and older models and versus newer models that we need to look at. I think, people are looking at a more agile system, right? How can we be a little bit more responsive, adaptive, regenerative, whatever we need to do? It's interesting though, because the pandemic was such a shock to the system and everything has just been, in a chaotic, if you will. But even coming back, I just came back from a trip talking to CEOs at different companies and, they're also hesitant to adopt new models because it's like, what if this is a one-time show? We move and we change everything. And then now we're in another problem situation, right? So this is again, where we do have to leverage the conversations between academia and industry and not silo things anymore so that we can actually help one another. And which has really been a big problem, right? We've siloed ourselves from one another for so long. Even talking to that business group, they make the comment, you're an academic. We don't like to talk to academics because they're just the ones in the corner. They're so full of their own heads that we don't understand them essentially. And I think that's something that academics have to understand about themselves. We have a lot of knowledge, but we have to learn to speak the language of the industry and to be able to help. And so we're going to have to learn a new language to really bridge this global gap. And I think we're going to be teaching our engineers of the future how to have a different language, because you can learn your discipline, you can even take interdisciplinary courses, but unless you know how to talk to people, it really doesn't matter what's in your head, right? And I think you're probably realize this in your own career. You have to kind of learn to talk the universal language to really bring people into your idea or bring people along and help them to understand. And so I think that's a skill set that we have not really focused on, and we'll have to do a better job of that. I saw Cliff put in the chat, we're not, bounded by proximity anymore and making collaborations and, talking about where these discoveries can come on the cusp. And that's exactly true. We now have the ability to stretch ourselves, but the way it's going to be successful is how do we actually engage with one another? I can talk to somebody in France or anywhere and I can, we can talk about things, but are we really going to be engaged in solving that problem? And so the language of how we work with one another is really going to be key. And I think students coming out, students want to be able to talk to one another. And I try to stress that in classes and try to stress that it's beyond just the disciplinary work. There's also the professional development to be ambassadors for the field. So
I think co-op does a very, very good job. Specifically for me, I felt the positive effects of the co-op program of speaking the discourse of the professional discourse and being able to link it back to the academic discourse at the same time because of my experience with co-op. Professor Makowski?
Yeah, I mean, I think about this as having to re-engineer for a crowded planet. I mean, we were stress tested to the extreme. There's no question, and it's hard to imagine a system that that was going to not take a hit given everything that changed in early 2020. But obviously, just in time, resourcing is not going to give you the resilience you need when a stress test comes along. But I also think that I think in terms of slim engineering, I'm not sure I'm using that term right. I know people use it, but I think of basically engineering devices without all the bells and whistles is what I'm thinking about. One of the things that happened in 2020 was that there was suddenly a worldwide shortage of ventilators. And suddenly everybody was looking for ventilators. I get calls from Africa. Can you find me some ventilators to ship to Africa? And and the answer, of course, was no, because every ventilator that was going to be built for the next year had already been ordered and purchased. But what happened was, and I think it was GE Healthcare got a huge order for ventilators without any bells and whistles. Let's just get a ventilator that works out the door without all of the extras. And it was 1/8 the price of your standard ventilator that would go into an ICU in a hospital today. And they were able to get it out the door really quickly. And I think that if you want to be agile to the disruptions that are going to happen in a crowded planet, one of the ways of doing that is really looking harder at efficiency and slimming down some of the design requirements. You may not make so much money per unit by doing that, but I think there's a lot to be said for doing that. And particularly, I also spent some time just before the start of the pandemic in early 2020 looking at healthcare in rural Ghana, and the needs in those parts of the world, which are becoming more and more connected to our parts of the world here in Boston, are very different and require a completely different set of engineering. So I think as we move to a more crowded planet, that re-engineering for that crowded planet is going to take some real changes to the way we think about engineering and what we really need.
Yeah, what you said about the ventilators actually reminded me of something very interesting. During the summer 2020 period, there was a big ask from the government to figure out a ventilator situation and re-engineer it. And a lot of startups jumped on the opportunity. Yep. And this was an engineering collaboration of different disciplines that came together to really pump out something useful and that would save lives and can be put to the field really rapidly. Professor Tadigadapa, your hand is up.
Yeah, I think Lee said some things that were very much what I wanted to say, but there is the other aspect. I mean, pandemic, of course, is an unexpected, sudden event. But we also know that we are heading, for example, with the climate change and, where we are heading, this is a slow, process, but we are heading towards a place where we are going to be increasingly resource constrained. And that includes energy and efficiencies and the kind of things that Professor Makowski just talked about. I think a lot of our engineering is going to head in this direction. And I think while we may not be exactly thinking of the next sudden event, whatever it is, I think the technologies that we will be spawning as we go and think in these terms is very critical. I mean, whether whether it is distributed energy, whether it is communications, and as I said, augmented reality, where maybe you can do remote training, and how do you? It's not just one. It's one thing to watch a video, but it's another to almost feel what it is to learn. Like if somebody is standing next to you and telling you what to do. These kind of technologies are going to be increasingly part of that world where efficiency is part of it. And hoping that those efficiencies and those, will allow us again to pivot to this next unknown, challenge that we may face. And of course, if not, we are actually preparing ourselves to face towards, for that eventuality that we are heading towards. And so that to me is actually the most interesting challenge that we have. And that slow target or that slow goal that we have that is coming our way is actually closer than we think. And there is actually a great amount of urgency in bringing all of us together in every one of our fields to truly address it. It's not any one of us that can actually do it. And so that to me is really why I think this collaborative background and, hopefully with the co-ops and industry and all of this will come together from our Northeastern's perspective, at least.
Yeah, it's a great point. Actually, while you were talking, another question came up in my head that is about preserving the education and the knowledge that we've gathered through this experience, and preserving it and teaching it and keeping it going forward. How is that going to come into play in education, specifically in higher education and in engineering? And how is that going to keep going? Professor Hajar, do you want to take a crack at this question?
So yes, one of the fascinating things that came out of this really unfortunate pandemic, if you think back to April, May, June 2020, you may recall there were reports that came out that talked about the dramatic decrease in pollution and the shifts in energy use and the potential impact or perhaps window that we got into some of what we're trying to do to address climate change. And that data and information may be gone in the eyes of the public, but it's not gone in the eyes of the people doing the research in these areas. And it gave a pretty massive experimental data set on what we've been struggling to do for a lot of years. And I think it provides a window into what we're going to be needing to do, provides an opportunity to think about and project out better what some of the adjustments that we might make, like electric vehicles, how they might impact. And then I think over time, these ideas are going to be getting into courses. And we'll start to integrate some of the lessons from the pandemic into the courses on this. There could be other related ones I was related to transportation planning and things like that as well.
Yeah, that's very good point. Really interesting about that window and climate change, but keeping it going with industry. Sometimes with climate change, there's a bit of a disconnect between industry and academia, and it's a tough gap to bridge without market forces entering and forcing that to happen. So the best way we can arm ourselves against the potentially looming disaster is teaching the kids and having them go out and be the advocates for that. So it's great to hear that that's going to propagate through. I would love to give an opportunity for you guys, everyone on the panel, to talk about anything that you guys have seen that was interesting. Maybe give us a bit of a sneak peek as to what you guys are working on in the background, kind of a bit of an unstructured end to this chat here. I'd love to hear any lasting comments that you guys have. Volunteers, or I can pick on people.
I can go first.
All right.
I'll go briefly since we're running out of time. I think, I'll just speak from as a department. I think what we did was we went through an exercise. We have about 70 faculty, and we went through an exercise of really redefining our research areas, especially in the context of everything that we've been through and the interdisciplinary overlaps that we see. And so just kind of trying to think about the social, technical, side of things in addition to the actual research. So not forgetting all of the societal impacts of the work and really rejuvenating our work in manufacturing and thinking about it in an intelligent context and with the technology of robotics and, things like mixed reality, virtual reality, and working with other departments. So that's something that we've been brainstorming and going through this exercise of this past year. And it's really rejuvenated the faculty and got them really excited about the future.
Professor Makowski.
Yeah, I mean, the pandemic really sort of put bioengineering in bold italics and large font and a lot of visibility. And it really is biological research, in general, is really at a cusp, because I think because of the combination of genomics and proteomics and the ability to collect data at huge data rates, big data, our ability to sequence, our ability to search data and analyze data at very, very large scales, store huge amounts of data. We're finally getting to a point where we can start to really grapple with the incredible complexities of biological systems. And I think it's going to give us huge opportunities in the future to address as quickly as possible the kinds of challenges that the pandemic put in our laps 2 years ago.
Professor Willits, we haven't heard from you since the beginning of the conversation. I'd love to hear some parting words from you.
Similar to what MIE has done, we really rethought how we can focus our research areas on solutions to these problems that exist at various levels of the global society. So I think that in that, chemical engineers, and we talked about this at actually our national meeting, chemical engineers are not always kindly looked upon. I think between any kind of petroleum or fossil fuel issues and we maybe cause environmental issues, so I think that idea of what a chemical engineer is really redefining what we do, because that's not, at least at Northeastern, that's one, not our focus, but two, our students, just like the global student now, wants to impact these problems, right? And not contribute to any problem. So that idea of how do you get all of those different inputs for what the impact of what you're doing will be? How do we carbon neutral things? And how do we, how do we do all of, how do we produce a vaccine at ultra low temperatures in carbon neutral ways? I mean, like that, those are where chemical engineers could really have a role. And I think that that's something that we have to be better as chemical engineers at doing and saying that we are part of the solution. And I think sometimes in engineering in general, we really kind of go at the discipline in very, in ways that is historical versus ways that are what's the future. And so I think that looking toward the future is the pandemic has really pushed us to trying to solve a lot of problems that just, like I said, some of them don't exist yet, but we see them coming down the pipe. So.
Yeah, that's that collaborative experience and the multidisciplinary experience, I think, is the way to go. I know from us and our team, I'm an industrial engineer, but I do computer engineering things constantly. My mechanical engineers do environmental and industrial engineering things every day. So that's becoming a commonplace on a daily basis. We're coming up to the end of our session here. I want to thank you guys all for participating and being here today. I want to leave it for any parting words. I don't know who's going to give closing remarks. All right, Dean. Mike, back to you.
Yeah, okay. Thank you very much. And I want to thank the chairs here for engaging in this conversation. And I really appreciate everyone joining to talk about this. One thing I also want to leave you with is not directly related to the pandemic, but there was this question about where is engineering going in the next 5 to 10 years. Northeastern is at a very interesting place now, and place is an interesting word for me to use because if you're paying attention, you'll notice that Northeastern has a growing a network of campuses around North America and one in London, and with plans to expand beyond that. 2 of those other locations have significant opportunities for undergraduate development. The majority of the other ones are mostly put in place initially for doing graduate education and some research. I think in the coming 5 to 10 years, you will see Northeastern have the opportunity to produce very novel approaches to undergraduate education that leverage the fact that we are in many places at the same time. One of the reasons I feel optimistic about that is because of the pandemic, we are all more comfortable, and we're forced to become more comfortable with the use of remote technologies to support interactions with people in different places. Now, as we're moving back into more kind of hybrid situations, we see the challenge of these kinds of mixed mode experiences. There's an opportunity there for us to improve technology, to improve these kinds of interactions that Northeastern is going to have more and more of. People in different locations needing to have significant collaborations and interactions, not just as researchers, but as students taking classes and learning collectively. So I'm looking very much forward to how we can innovate in that space over the next 5 to 10 years and grow our presence as a global university. With that, I'd just like to again thank everyone for coming. And if there are any follow-on questions people would have, feel free to direct them to us. And I look forward to further engagements with you all. Thank you.